Hello everyone, Plus2 here. We are doing level 3 complex numbers algebra 2024 today. I find this year is quite different from previous years. I like it. Right, start with question 1a. Given that x plus 3 is a factor of x cubed plus px squared plus 5x minus 12, find the value of the constant p. So it's factor theorem, isn't it? So I let the f of x be this expression. So if I plug -3, then I will get 0. That's what it means, right? So it turns out p is 6, right? Question B, if z equals mcis n pi over 5, where m and n are positive real constants, then find the z to the power of 15, giving your answer in polar form in terms of m and n. So as you know, the reason why we use a polar form is because of this product rule, isn't it? So z to the power of 15 becomes m to the power of 15 cis n pi over 5 times 15. That's the product rule. So you have to say m to the power of 15 cis. So simplify this. 3n pi should be the answer. Solve the following equation for x in terms of k, where k is a positive real constant. So what I recommend is, square both sides. 4 minus square root of kx becomes a kx, hold on. Oh yeah, that's right. I switched that. So square root of kx plus 4, you square it, so just kx plus 4. And minus square root of kx becomes 16 minus 8 square root of kx plus kx, isn't it? So kx cancels out. 8 square root of kx becomes a 12. Hence, square root of kx becomes a 3 over 2. And you square both sides, leaves a kx equals 9 over 4. Hence, x equals 9 over 4k. So times by 1 over k on both sides leaves the answer. All right, question D. The locus described by modulus of z minus I equals modulus of z plus 1 is a straight line. Find the gradient of the line. So I tell you what, when it comes with the locus question, you always set z be x plus yi. Then, so you plug x plus yi into z. So I simplify the inside. So real part and the imaginary part, right hand side as well. And then because it's a modulus, square root of real part squared plus imaginary part squared, but both square root. So I square root at the same time. So x squared cancels out, and then I expand both y minus 1 squared and y plus 1 squared. So, and then simplify. What left is 4y equals 0, y equals 0. What is it? That is x-axis, isn't it? So, which has the gradient of 0. So, the gradient is 0. Question E. Consider the complex numbers u equals 2 plus 3ki, v equals 4 plus 5ki, where k is a real constant. Show that the complex number w equals uv will not lie on the line y equals x in the Argand diagram for any value of k. So y equals x means the gradient of 1, isn't it? 45 degrees. So if we change this to polar form, the angle must be pi over 4, right? Well, the gradient must be 1. So with that in mind, first of all, w is 2 plus 3ki over 4 plus 5ki, isn't it? And then we rationalize, meaning times by 4 minus 5 ki on both sides, leaves that. Yeah. And then I separate them, real part and imaginary part. Now, that is W, right? Then what I did is I found the theta, so angle. So that means because this real part is A and imaginary part is B, so tangent inverse B over A is theta. So 2ki over 16 plus 25k squared over 8 plus 15k squared over 16 plus 25k squared. I simplified, so 2k over 8 plus 15k squared. So as I said, y equals x has gradient of 1, which means that m is 1. This means 8 plus 15k squared must be 2k, isn't it? So that means that 15k squared minus 2k plus 8 must be 0, right? And um, then means, and it says will not lie on the line. So that means there is no such a k satisfying this. That means discriminant b squared minus 4ac must be negative. So there is no solutions, no such roots. So which means in this case 4 minus 4, so b squared minus 4ac, so 2 squared is 4 minus 4, 15 and 8 is negative. Well, it is negative, isn't it? Yeah, because 4 minus such a big number, yeah, it is negative. So that shows no solutions. So you can conclude that no such k make w lie on y equals x. All right. So this question requires some abstract thinking, I believe. Question 2. Write the complex number I over 2k plus I in the form of a plus bi, where a, b, and k are real numbers, giving your answer in terms of k. So I rationalize it. So times by 2k minus I on both sides. So that leaves that. And then I split into real part and imaginary part because that's what it asks. So 1 over 4k squared plus 1 plus 2k over 4k squared plus 1i. Find the values of r so that the quadratic equation 2x squared plus 3 plus 2rx plus 3 minus 2r equals 0 has equal roots. Equal roots means what? Discriminant is 0, isn't it? So in other words, it's one root. Yeah. So b squared 3 plus 2r squared minus 4ab must be 0, right? So then you simplify. Yeah. That must be 0, right? When you solve this quadratic equation, you will find r equals to half or negative 7.5. Okay, question C says given that w over w plus I equals 2 minus I, find modulus of w. So let w be a plus bi. Yeah. Then I rearranged it. So w equals 2 minus I times w plus I, right? Which is that, right? I just, rearranged it and then expand and then simplified. So organized it, real part and imaginary part. So because w is, I defined the w is a plus bi. So a is 2a plus b plus 1. In other words, a equals minus b minus 1, and b equals 2b plus 2 minus a, which is b equals a minus 2, right? So I'm going to use the substitution method to solve these simultaneous equations, right? So I plug a minus 2 into b. So that means a equals minus a plus 2 minus 1. 2a equals 1, and hence a equals half. Because a is half, b must be negative 3 over 2. So it says find modulus of w. So that means this is not it. You have to find the modulus of the w. The square root of a squared. So square root of half squared plus negative 3 over 2 squared gives you square root of 10 over 2 is the answer. All right, question D. One solution of the equation is such: if D is a real, find the value of the and the other two solutions of the equation. So this is like pattern. So, each year you find this question, right? So because one solution is a 6 minus 2i, the other must be conjugate, isn't it? So which is a 6 plus 2i. So with that information, we can build this quadratic expression, right? So you expand. But I recommend that you do not expand that bracket. You can just calculate in your mind. So that comes out z squared minus 12z plus 40. So that must be one of the factors. So quadratic times this linear gives you this cubic equation, right? So that's how I could build 2z plus a. A is just like we are gonna find what a is. Yeah. So I'm gonna teach you easier way to find the answers. So once you find the a, then you can find d. So also you can find the last solution. So second solution is a 6 plus 2i, isn't it? So here, so what I did is I used the terms with a z. So to make a z, it's got to be negative 12z times a, so which is a negative 12az plus 40 times 2z. That's the only chance you can have is the term with the z, right? So and it says 140z. So it means negative 12a plus 80 must be 140, right? So that means negative 12a equals 60, hence a must be negative 5. Right. So knowing that a is negative 5, so you find the d. So you have to find out the terms with the d squared. So it turns out d is negative 29. So you found the negative d, the value of d, and then the two other solutions must be 6 plus 2i, and because a is negative 5, the solution must be 5 over 2, right? That's how you answer the question. Right, question E. The locus of a complex number z is described by that. The complex number u equals 3 plus di lies on this locus. So this year I find that lots of loci problems. Find the Cartesian equation of the locus of z, giving your answer in the term form. Yeah, so this is a circlism. And also find the complex number u. Right, so again, do you remember? If it is a locus problem, you must say z equals x plus yi. And plug that into the equation is that, right? And then you simplify, so square root, but I squared both sides. So that's why 2 becomes a 4, right? And then this is a bit tedious, but you have to do it. You have to expand and you simplify. So it's all the way here, right? So when you expand there, and then you put the terms with x and terms with y together, and the right hand side is just number. Don't worry about like a right hand side becomes negative. We will sort that out because yeah, first of all, divided by 3, and then you have to use completing the square to balance it. So see, x squared minus 10x, so half of negative 10 gives 5, right? So x minus 5 squared gives me x squared minus 10x plus what? 25, right? So I add 25 here. And the same way, y squared minus 6y, that's a y minus 3 squared. So you have to add 9 to right-hand side as well. So that adds up to 8, right? So we completed the equation. So x minus 5 squared plus y minus 3 squared equals 8. So this is a circle with radius square root of 8 and the center 5, comma 3. Now, to find w, was that w? U, sorry. So you have to find the d first, right? So what you could just do, you just plug a 3 plus, so here u being 3 plus di, that means x value is a 3, y value is a d, isn't it? So you plug 3 into x and d into y to find, then you find the d first, and then you can complete equation or equations. So d minus 3 squared is 4, hence d minus 3 equals plus minus 2, hence d is 1 or 5. So when d is 1, you get u equals 3 plus I. When d is 5, u equals 3 plus 5i. All right. And question 3, write square root of 2p over square root of 2p minus square root of p in the form of a plus square root of a. So again, you have to rationalize, isn't it? So you have to times by conjugate, right? So that gives me, so the conjugate over the denominator is the square root of 2p plus the square root of p, right? So if you you times that to square root of 2p minus square root of p, you get 2p minus p, which is p. And then when you expand the numerator, you get 2p plus the square root of 2p, and you separate. So 2p over p is 2, and square root of 2p over p is square root of 2, right? So that's how you answer this. Right. In the Argand diagram below, the point negative 2, comma 3 represent the complex number z. Show clearly in the diagram below the point representing w equals z squared. So what you have to do, you have to find the z squared. So I just square it, use rectangular form. So that gives me negative 5 minus 12i, which is right there, right? So negative 5, negative 12. So you point it and just say z squared. And say the coordinates would be better. All right, question C. Find the values of the real constant d given that z equals 3 plus di and z bar. So it's a conjugate of z, isn't it? It equals 10d z to the power of negative 1. So z bar is 3 minus di, isn't it? Equals what? 10d over z, which is 3 plus di. So what I did is I times by 3 plus di. Sorry. All right. Okay. di on both sides. Okay. So that gives me, so 9 plus, hold on. Yeah. Then I switch the 10d equals 3 minus di times 3 plus di gives me 9 plus d squared, isn't it? So I put them in like one side, so making quadratic a quadratic equation, and it turns out d is 1 over 9. Okay, question D. All right. So solve the equation z to the power of 4 plus 81k to the power of 8 equals 0, where k is a real constant. Give your answers in polar form in terms of k. All right. So first of all, let's pinpoint the negative 81k to the power of 8. So somewhere here, isn't it? Because it's an all real number, so it's locates here. So that means, in other words, that's a 3k squared to the power of 4. I mean, I'm just changing to polar form. And because of the angle here, that's minus pi over 2, right? So I can rewrite like this. 3k squared bracket to the power of 4. Ci is negative pi over 2, isn't it? So hold on. Yeah. I think I made a mistake. I'm gonna solve this again. So this is a real number minus 81k. Say somewhere here, isn't it? So I can say I have to change this. So that's either positive pi. So forget about this. Sorry. Or you can say pi or this negative pi, isn't it? So I have to say this is 3k squared to the power of 4 CIS negative. Hold on. Yeah, CIS pi. Yeah, that's right. Yeah. Now, so Z being, I have to change this because it's to the power of 4. There must be 4 solutions, right? So pi divided by 4. Each time you have to add pi over 4 much. So the first solution is using the de Moivre's theorem. So that one to the power of, so I'm saying to solve this is to the power of 1 a quarter, isn't it? So a quarter, applies to this R, right? As like an index. So that just leaves 3k squared nicely. But inside argument, the angle, you have to go pi times a quarter, which is pi over 4, right? So the first answer must be, sorry, not this, it's pi over 4, which is 45 degrees. I'm gonna, yeah, so here, right? So that's a Z1, right? Z2 must be, I add pi over 4 much on that. So that must be Z2, Z2, I mean. Z2 is a 3k squared CIS to fix this. So pi over 4, and then I add pi over 4. So that means 3k squared CIS pi over 2, isn't it? So actually it's here. Yeah, right? Okay. And then you have to add. So what's gonna happen? You can keep adding pi over 4, I believe. So that is pi over 4, 2 pi, 3 pi over 4. So that's a 3 pi over 4. Now, then, oh, sorry. I know where I made mistake. I think I'm tired. It's not pi over 4 you have to add. 2 pi over 4. Yeah, that was strange. So 2 pi, yeah, you have to split 2 pi, one revolution, into 4 parts, isn't it? So that's a pi over 2. Sorry, I made a mistake. So the first one is right, pi over 4. And then you have to add pi over 2. So which means 3 pi over, this is a 3 pi over 4 is a second answer, right? So which is here. you can't add pi over 2 again because it passes pi. So this time this is z2, and then you have to take away pi over 2 from z1, right? So I go the first answer, pi over 4, take away pi over 2 gives me what? Minus pi over 4, isn't it? 1 take away 2. Yeah, that's right. That is a third answer. And then, so that's Z3. Z4 must be from minus pi over 4, and then you take away pi over 2 again. So that gives me 2, 3. So minus 3 pi over 4 should be the answer. All right. Is this last? Oh, it's not that last question. Well, I admit I struggled there. Okay. Okay. I'll just summarize this. So first of all, you have to simplify. I mean, you have to convert rectangular form to polar form, so that you can apply this de Moivre theorem to this equation. So z must be 3k squared CIS pi times a quarter. So that's the first answer. And then each time you add pi over 2 or take away pi over 2. Okay, so pi over 2 plus pi over 2, pi over 4 plus pi over 2 gives me 3 pi over 4. So that's there. The second, C2. And then Z3 is you take away pi over 2, gives me 3k squared CIS minus pi over 4, isn't it? And then finally, you take away pi over 2 again, gives me 3k squared CIS minus 3 pi over 4 is the last answer. Okay, question E. I think this is the last question. Given that x plus 1 over x equals p, where p is a real constant, then find the value of x cubed plus 1 over x cubed, giving your answers in terms of p. I like this question. I think this is a pure algebra rather than complex numbers. So if I double x plus 1 over x, square it, that's x squared plus 2 plus 1 over x squared, isn't it? So that's p squared. So I can rearrange this. X squared plus 1 over x squared must be p squared minus 2, right? And then if I multiply x squared plus 1 over x squared by x plus 1 over x, I get that. And that means, so x cubed plus 1 over x cubed plus x plus 1 over x is defined to be p. So I get that, right? So if I go p squared minus 2 times p, it means p squared minus 2 is x squared plus 1 over x squared, right? Times by x plus 1 over x. And then I take away p, then I get x cubed plus 1 over x cubed, isn't it? So that means when I expand this and simplify, p cubed minus 2p minus p, which is a p cubed minus 3p, is x cubed plus 1 over x cubed. All right? Good question. All right. I will see you later. Yeah. Bye.